Hello everyone. Today we talk about the project. The name of the project: simulation of an anti-tremor orthotic system for hand tremor. As you know, hand tremor happen in Parkinson disease. So the content of this project is a background of the Parkinson disease and classification of the tremor for Parkinson disease. Vibration absorber, example of vibration absorber, tremor control device with gyroscope clause, mathematical model, simulation, goals, prototype, sensor wiring diagram, design, assembly, and Arduino code. Parkinson disease, or PD. PD is a neurological syndrome which arises due to the shortage of the dopamine producing cell that allows to the brain to transmit the signals. The most common side effect of the lack of the dopamine are tremors. Patients diagnosed with Parkinson disease range from 20 years old to 80 years old, with the average age at 60 years old. Parkinson disease tremor can be classified into the postural or kinetic tremors. The tremors usually started on one side of the body. Eventually, both sides will become affected. Unfortunately, there is no known cure for this movement. The only thing that can be done is to manage the symptoms. There are medicines available right now that can help manage or stop the tremors. However, like most medications, there are always side effects that can be worse the situation. Generally, it will affect the daily activities and can disturb the human body. Tremor is classified by relatively low amplitude, relatively high frequency, and the frequency is between 4 to 12 Hz. So, classification of the tremor for Parkinson disease, it might be you see the 9 different type of the tremor, but the 2 type of this tremor is for Parkinson disease. One of them postural tremor and the second rest tremor. As you see, postural tremor is the frequency of the postural tremor is 5 to 9, and the rest tremor is 3 to 6. Occurrence of the postural tremor when hand joins together and against the gravity, and the position of the hands is against the gravity. Rest tremor is when you're in a rest mode and your hands and your muscles is not against the gravity. And the tremor classification, as you see in the other side of the table. Vibration absorber. Vibrations can be controlled in many ways when a system is subjected to the continuous cycle motion of a structure or an component. A vibration absorber is made up of a secondary mass which is mounted on the base system using a spring and damper. To control the vibration, the frequency of the vibration absorber is set up in such a way that it will be matched with the frequency of unwanted vibration in the primary system. There are 3 basic types of vibration absorber system. As you see, passive system, semi-active system, and active system. Mostly, the passive method consists of a spring and damper, which help to reduce the vibration. Semi-active system vibration control are tuned as per the operating condition. The active control system is made up of sensor, actuator, and feedback circuits. The main purpose of an active control system is to suppress the vibration amplitude. In this page, example of vibration absorber. In the left side, you see the three types of the beam and cuff mounting vibration absorber for Parkinson disease. On the right side of the page, the first one, low anti-vibration gloves, second one, elastic vibration absorber gloves, and the third one, mass and damper, or mass and spring type of the vibration absorber for Parkinson disease. Tremor control device with gyroscope gloves. As you see in this picture, when the hand experiences a tremor, the stability of the gyroscope helps to resist tremor movement by keeping the gyroscope spinning in the same plane. So that the small tremor movements are resisted by the gyroscope force, yet allows for the intentional and deliberate movements to occur. So a mathematical model. I create a mathematical model for a gyroscope, as you see in this video, and lever arm test calculation. So in the next page, you see the calculation, the momentum calculation, and the torque calculation, and the angular velocity calculation. In this page, I simulated a human arm without a vibration absorber system. A similar model containing vertical and horizontal and rotation system. As you see, the simulation result of displacement of hand without a vibration absorber system in horizontal direction. You see the diagram in the top left side. The result were carried out in a time and frequency domain for a period of 10 seconds at 3 Hz frequency. The result of the hand without the vibration absorber system were in the range of minus 1.5 to 1.5, and the amplitude of harmonic displacement remained constant. A similar result of displacement of hand, the second diagram, with the vibration absorber system in horizontal direction, and the result were carried out in a time and frequency domain for a period of 10 seconds at the 3 Hz frequency. You see in the second diagram, it happened that the reduce of the vibration, it happened, So, goal statement and product specification. The goal of this project is to create a system that use the gyroscope to stabilize hand tremors. You see the aim of this project. The weight of the part of the project is near to the 1 pound, and it's allow for full flexible wrist movement. The sound of the rotation of the gyroscope rotation near to be 80 decibel. Dimension of the project, you see that, and effectiveness and sensors. As you see, the prototype of the project, the element I used in this project, power supply, electronic speed control, motor, I used the brushless type, Arduino microcontrol, gyroscope, voltage sensor, RPM sensor, MPU sensor. Sensor wiring diagram. As you see in this picture, in the left side, you see the Arduino microcontrol, and the top of the left, you see the voltage sensor. In the right side, in the down part, you see the MPU sensor, and the top is the RPM sensor. So, design of this project is the main 5 parts. The first one is the base fan, as you see in a black color, the gyroscope in a yellow color, and cradle in a red, base 2 in a blue, and cover in a green color. I designed this project in a SolidWorks. You see the exploded view of final assembly. You see the every part it's assembled together on a hand. After I designed this project in the SolidWorks software, I 3D printed every part and assembled them together. You see the body part and gyroscope spindle and the sensors together. And after I tested on my hand, you see how is it good to fit on the hand. In the end, I wrote it down Arduino code for control the sensor and the brushless RPM. Thanks for your attention.